Yeah, just started recording because this is a good conversion. So through this, what we are doing is we are actually minimizing the blast radius per se, right? So
Yeah,
instead uh of we losing out on data for 5 minutes and of having that sort of risk versus doing it just for that like few milliseconds, like write happened to the database and then I'm doing this. Because in that case, if my write to the Kafka failed, then I'm over counting things. Correct?
yeah,
So my count in the database got updated. Then write to the Kafka failed. So write to the Kafka is in basically
commit.
when you commit to the corresponding message, right? If that failed, which means that you would be over counting things. Correct. Now versus if you're batching it at first and then doing commit at that time, so you'd be under counting things and not over counting. And even if it fails, you can always retry, right? So that is a great advantage that you'll get. Number one. Now, the insight that you brought up with respect to uh, accuracy for some and being approximate for others, that's a wonderful insight. A lot of platforms are built around this thing. So in the eighth week, when we'll go through the algorithms, we will see a couple of algorithms built on this insight and how it makes things interesting and efficient. So what we would, your insight is how you can make this conditional is depending on the topic that you have. Like create, so instead of having one topic for one event, for this thing, you might want to have like two topics, one high priority or you can basically bucketize your users. One having less than K followers, another one having greater than K followers, right?
Yeah,
And for some, you would want to have like very accurate count. For others, it's okay if you have it approximate. LinkedIn suffers from this problem because LinkedIn is where Kafka was born. So they had everything done through, so they had everything being done in an asynchronous way. So they had written a massive blog stating that we don't have anything synchronous. They have everything asynchronous. So when they adopted that, you'd see a lot of lag, a lot of things being eventually consistent because message passing, consumers consuming, and then writes happening. It takes a lot of time, right? So this was a problem with LinkedIn. Even today, the counts of your post, like, share, and sub, and these sort of things, they mismatch. So this is what you, so making it approximate. So for a small creator, every like matters. For a big one, it's okay if you lose out on some data. So for something, you can make things approximate. Not just with respect to data loss, like instead of having a full-fledged doing a count plus plus every time, or rather count plus equal to your batch count every time, you can actually use an approximate counter which takes in less space. It might be an overkill for this use case, but you can go with that approach. Key, let's have just one write sampled across 1000 events, something around that. So sampling is something that you can try out. That helps a lot. So hyperlog log, have you read about hyperlog log?
no,
So hyperlog log is approximate counting sort of algorithm. So Redis very well implements that. So just check that. So for people, like for example, let's say if Sachin Tendulkar posts something on Instagram, he would get a ton of likes in a few minutes. In this time, you'll see a very high influx of events coming in. So would you want to handle this much of influx of events versus can you make it approximate? Right. So one strategy to apply here is to not even take in every single event, every single write event that happens, like even sample them for certain accounts which have number of followers greater than K. So you have to bucketize your users, you have to bucketize your creators into buckets depending on the kind of approximation it can bear. It's a very advanced sort of thing. You might not do it on day one. It's basically sort of like once you cross 5 billion, 10 billion worth, having like your average, your or some of your users have followers more than 10 million something. That's when you would start kicking in this approximations. So sampling even the writes that go to the database. There are tons of optimizations around this space. Like, and as you rightly put, these are all based on intuition. Like people having less followers needs to the data for them needs to be more accurate versus for the one, because they don't even open their Instagram account. There was this tweet that some famous celebrity made around this very thing. So Instagram never treated, so it was 2014-ish time, something 2014, 2015 something, and till that point Instagram never differentiated their users. So which means that similar to how you get notification on every like you receive, even celebrity used to receive notifications on every like they receive. So that happened that one of the celebrity posted something, that celebrity got a million notifications. Like the phone was continuously buzzing and there was no way to stop it unless you just basically shut down your phone. And he took he or she, I'm not really sure who he or she was. The celebrity took the other phone, recorded that thing. He see the kind of notifications I'm getting, and the very next week Instagram started bucketizing their users. So that celebrity actually made that actual tweet. And since then, this sort of bucketizing your users became a norm for all the companies. So they stated the major problem that this thing had, and they started rectifying it.
Great. Actually, yeah, nice to know about that optimizations. And yeah, I mean, anyway, we'll see them in week 8. So yeah, waiting for it.
So, Abid, what was your toughest interview ever?
अरे my toughest interview, just give it answer. एक मिनट. My toughest interview. Interesting question. Let me start that. My toughest interview. Okay. My toughest interview. You won't believe my toughest interview was with Moonfrog Labs. So those people asked me some really stupid, they asked me a really simple question which I struggled a lot. They asked me about reversing every 2 nodes of linked list. And I was like, and although basically that was a pretty standard question, I was not able to solve it because the interviewer made me tensed from t=0. So since the time the interview started, I was like really being grilled down on the topic. Like he made me really nervous, and I was just 1 year old in the industry at that time. So that person made me really anxious, and because of which the interview became tough. It was not the question, because the intuition was not tough, but the atmosphere made it much tougher. And that is where I realized that to make interview tough, you just need to put pseudo pressure on the candidate and just see how he or she reacts in that situation. Because question tough is still okay, you can still survive that, because the interviewer is there to help you. So you would anyway survive those part. uh with respect to concept, obviously there is nothing that you cannot learn, because everything is like wide open. It's just that you might not know it during the interview, but after a day or two, when you go back and you retrospect, you would obviously understand that part. So it's mostly around the atmosphere and the way interviewer puts pressure on you. Even Amazon was pretty simple. Unacademy was pretty simple. Practo was simple. Moonfrog Lab mein anxiety, it kicked in really high. The Rippling one was a very tough one. I applied for Rippling in 2016. No, 2017 I applied for Rippling. They were just setting up India office at that time. The question that the interviewer asked was very simple. OS scheduling pay question was there. I had to write a very simple locking on data. No. The question was really simple. Acha, हाँ, correct. I just wanted to create a process scheduler with locks. So once the process starts, it might need to take locks on certain entity, and that's it. You just have to create a process scheduler around it. It was a very simple question, but the kind of questions the interviewer asked me, they were so grilling. I never thought of this situation. I never thought of this situation. And then I was like under this constant thing ki, Arey, I've never even thought of all of this, of all of these peripheral situations, all of these edge cases, which made it really tough. So it was just that when interview typically dives deeper into stuff that I don't know, that's where the interview becomes tough. But if you know the concepts well and and basically know your things well, it's not that hard.
Yeah.
But
Thanks
with
for sharing,
respect to, yeah, but basically with respect to content and all, or technical knowledge and all, it is never tough, because like you are not supposed to know everything. I say this all the time. We are a very unfortunate profession, because like you never expect a doctor to, to basically practice his or her practice in weekends. Like you don't expect your doctor to learn जो है वो neurosurgery over weekend, but you expect a software engineer to be upskilled every time. Right? So that's a really sad part. But yeah, that's how industry is functioning right now. They've just shifted the entire median towards being like constantly upskilled and all. Sad part. Chalo. Acha, before we jump to the second part of social network, I just wanted to have a very quick discussion around yesterday we were discussing about profile pictures updation. So there were two approaches through which you can do it, like basically creating soft links to URLs and uploading at the same path on S3. Right. So can anyone elaborate, or did anyone did some research around it to see exactly how you can do it? If you'd want to bring it up onto the table. The reason I'd want to pull that out is because through that you are essentially tackling 3 or 4 different system design. Like for example, if someone asks you to design gravitas, this is exactly the core logic of it. Right. So how would you exactly do that? Anyone would want to pitch in? No?
I mean, the simplest way I can think of is, I mean, in the bucket, you just delete the file and create another one. That's like,
With the same path. So basically uploading at the same
yeah,
uploading in the bucket at the same path. Correct.
yeah.
But
Yeah,
can you
or-
create a symlink? Basically a web-based symlink to a URL.
We can have a pointer.
Hmm.
I mean, basically a database of
How will you implement this pointer on web? That's my question.
Aren't S3 bucket supposed to have a proper directory which you send it files, right? Like
So S3 is just like a cloud directory. You can
on
create as many folders and files there.
what
Right.
I'm trying to say is like like you would structure on if very naive way would way,
Hmm.
like you would structure your user directory in such a manner where let's say since user would be created, so we don't have to worry about if the post is being created or not. So user/user ID, something sort of an internal directory where you user/user ID /profile.
Yeah,
This would
that is
be
there. See, Pranam,
Uh-huh.
that is exactly that. But वहाँ पे is not a concern. But how will you actually implement it? Like, for
Redirect.
example, on S3, I have images bucket, and in bucket, I have, let's say, profiles. And let's say my user ID is 123.jpg. So
Okay.
every time user uploads any photo or updates the profile, it always gets updated onto this very path.
yeah.
Hmm.
So this path would be saved in database, right? That what is the profile,
Correct.
right?
Correct.
So in the database, so I'll be having a table which shows a current path. Okay, is this current? Is current? Then current would be pointing to this 1, 2, 3 path, and if it's changed to 4, 5, 6, then the current will be mapping to.
Where it would point it?
So there will be only one column for, I mean, one column for what is the current value, and there would be the value of what it's pointing to.
Yes, no doubt. See, this works in SQL world, right? Where every time you are, let's say you want to fetch details of a post. So the problem here is, let's say if we are building Facebook pay a user made 1000, or let's take example of Twitter. Let's say we're building Twitter, one user made 1000 tweets. For each tweet, you would be having a user detailed feed into the response of, or basically how a tweet would be represented in JSON. So that user's detail object would be within that. If you're storing data denormalized, you would have this user detailed copied on every post.
Yeah, that's correct.
So now in that user detail object, there will be a photo URL. Correct. Now what would happen is when the profile picture gets updated, all of this 1000 tweets a user detail object needs to be changed. Correct. This is where this would become inefficient, right? Something that we discussed yesterday. Now one way to solve this is like have a same static path for a user. Let's say /images/profile/user_id.jpg. Anytime user uploads a new profile picture, it will replace this existing file, which means even though the file URL stays the same, if the file in the source like S3 gets changed, when it is rendered, it will be always the new photo which is being shown. Correct? So you don't really have to go and update the 1000 tweets made by that user.
Yeah.
Right. So this is something that we discussed yesterday. So one of the approach to solve this problem was to upload the photo on the same path so that a photo URL of a user always remains constant, which is this /images/profile/123.jpg. So depending on what the user ID is, you might have the corresponding user ID. Right. The other way to do this is like how would you do it? Like, because here another challenge would be what? Let's say user uploaded something in PNG. Would you on the fly change it from PNG to JPG? Because it's not that simple of a problem. Right? How will you address this? How will you address this problem? And one of the approaches that I could think of is something that we did yesterday. Making things on demand.
Didn't we agree on that Event Bus Traveling to having an image service where it would do this for us yesterday?
Yeah. So that would do it, right? But update kahan hoga? See, somewhere it needs to see. What we are trying to save is updating 1000 tweets made by the user, right? If the data is denormalized, which means user's profile picture URL is stored at 1000 different places.
Also, just to clarify, aren't we are we changing, like, are we keeping this profile picture as a static URL, as in which I mean to say is images/profile/user_id.jpg?
Correct. Yeah.
So this can be also a specific static link, which can also be hard coded on the front end side. So every time the user updates, it will eventually point to that user ID.
Yes.
Right?
Yes.
We don't have to manually change the JSON.
Yes.
All we need to do would be max to max would purge the cache on the CDN.
Yes.
That's about it.
Yes. See, Symlink is very hard to implement. A lot of people do it, but the way you would be implementing Symlink, I know one way to do that. I'm just curious about other way to do it. So what I would have done is, let's say we are designing this Gravatar sort of stuff. So which means that there should be one URL which you hand out to any service you would want. And when someone hits that URL, it gives or it sends you the most recent profile picture of yours. How many of you know about Gravatar? At least one person know. If you don't know, just immediately switch the tab, Google about it. Gravatar. It's just unified global profile photo service. So it's just that one photo URL. So it is typically linked to your email. So you might have seen that when you sign up on a certain on a certain set of websites, it automatically gets your profile picture. If you don't even sign in with Google or something, it still gets a profile picture. It might be a very old profile picture that you might have used when you created your Gravatar account. But that is something that is there. So one URL hitting which you would always get your latest photo. This is what we are trying to do. Like this is just like out of the box discussion, but like implementing this, there are two ways that I know to implement this. One of them is like uploading the photo at the same location always. Second one is symlinking, but not exactly symlinking, but how would you actually implement that? So I have one way to do it. Let's do this thing. Let me so yeah, go on, Piyush.
Okay, so like again a very naive approach, but what we can do is so at a given time, let's say for profile 123, there would just be one file which would have name 123 dot and then some extension, right? So let's say now the user uploads a PNG image, right? So we would call a service like the backend service. What it will do is it would go to our S3 and it would sort of do a wildcard search, like the profile name dot and star. So anything with 123 dot, let's say JPG and BMP. So let's say if we upload PNG, then the latest one would be 123.png. So it would fetch that and give it to us. Now the problem.
But how will
is
you
the
know
deletion.
which one is the latest one? So you are typically iterating through all the photos that are uploaded by the user, trying to fetch the latest one.
Not really iterating. We can delete this one. Like deletion would be the same when a user uploads a new image. That so what we'll do is we'll first check again like 123 dot and star. So we will delete everything that is 123 dot star. So
let's do one thing. This is basically turning out to be a very interesting design question. Okay, let's just take it like out of the box and let's just design this thing. Okay, end to end. So we'll all have to pitch in. Okay, I'll basically formally drop the problem statement. What we are trying to do. Okay, so what we are trying to do is we are trying to build Gravatars. Gravatars is nothing but one URL that gives that links your email or basically links your email to a photo, right? So this is something like if you upload your photo at one place, so wherever, so basically what we have to do is we have to generate a URL. Whenever this URL is hit by anyone, what he or she would get is your latest photo. So any photo which is updated there, it would get it. So URL to photo mapping, as simple as it. Now this URL has to be static. Okay, so for example, I create something like this: https://gravatar.com/arpit. If I do this, it would return me my photo. Let's say photo 1. Now let's say I want to update my profile picture. Now this Gravatar, this is nothing but an image URL which you can use in IMG tag. So IMG src equal to, if I put this, it should render my photo on the web page. That is condition number 1, because otherwise this URL has no sense. Correct? I should be able to use this URL in my IMG src tag. Correct. And now this is where I uploaded my photo 1. Let's say I go to gravatar.com and I upload photo 2. Now this photo 1 was JPG. Photo 2 was PNG. Okay. And now this photo 2. So what happens is I can have transparent backgrounds in PNG, but not in JPG. So my photo 2 is a transparent background photo. So I cannot even like convert it into JPG and do it. Right. But now what I want to do is when I upload photo2.png, now when I'm hitting IMG src tag with the same Gravatar URL, this Gravatar URL, it should render photo 2. Correct. I want to design this system. This is not a problem at scale. This is a very simple thing to solve. The kind of design that I have in mind hardly takes one Lambda function to solve it. That is it. It's a really simple design. But let's tackle this problem around how would you address it.
Hey, so
First, yeah,
Arpit,
go on.
one quick question. Do we need to retain all the older copies of the photos, or do we
Yes,
just
let's
need to
do
have-
that. Let's retain. So people should be able to see all the photos that they have uploaded, and they should sit, or they should be able to mark which one is the current one. So you can always go back in time and say, ki, okay, this is my basically from next one, please use this as the photo that I would want to have. So retain all old photos and ability to mark as active. Mark one photo as active. So I can always go back and mark one of my old photo as active, and it should take effect. So anytime this image tag is rendered, it should now start showing me the old photo, or basically the one which is active.
Yeah, so it is simple, right? So we can have two directories, right? One directory will have all the photos, right? Starting from the oldest till the current. And the other directory will have just the current. So whenever a new photo is there, you add to the all the photos for a directory, right? With the latest timestamp and replace the current directory, which will only have one object.
Okay.
In that.
What would be your file name?
File name would be
See,
user
I have
and
JPG and PNG both. And you obviously cannot use cross file extension, basically cross MIME type thing you cannot do, because it has to depend on the MIME type of the content that you have in the directory.
No, but ideally, our current problem statement is to able to retain all the old photos and mark one photo as active, right?
Correct.
So, I mean, how does the extension of a particular photo here play a role?
So when you're uploading a new photo on S3, there has to be a unique path given to it.
Yeah.
That you cannot. Go on.
Yeah. So, but all the files can be of different data. I mean, extensions, right, on a particular path. Right. We are just be interested on the timestamp and the retention policy and marking one as current. So at worst case, we'll have redundant current photo. That's it. At two places. When the current photo is replaced by another new one, the current folder will have the new one, and it will also have a copy of that in the
Let's add this thing. Okay. Let me just pull in one more idea and then we'll start to formalize it. Yeah, Pradwan.
I wanted to suggest something, but if you want to take something, you can start.
Okay, okay. Let me just start with this one thing. Okay. So the first problem that we should definitely overcome. So if you see, this Gravatar URL does not have an extension here. It is just https://g.com/arpit. Right. This has to be something which is not related to any extension. So it should anyway, because our IMG tag is not expecting any extension whatsoever. So first of all, let's address the problem of uploading photos. Okay, let's just worry about uploading photos, not worry about marking it as active or something. Okay, so our first challenge here is, our first sub problem would be upload photos. Okay, so how will you upload a photo? It has to be like user from his or her device uploads a photo, it gets stored in S3. So upload from device goes to S3. But S3 pe what path? Any suggestions around path here?
Can it be timestamp based?
You can, if you're going for a unique ID sort of stuff, it is always better to use UUID or your own ID generator versus timestamp based. So timestamp up till milli would work, but two people uploading photos at the same time might have a problem. So what kind of directory structure would you have on S3?
For each user, I'll have a different.
So always specify, always be a little detailed around this thing, right? Shivam, please suggest a path for this.
Okay, so the path will be like S3 images / Shivam / something like current time.
Better would be user ID.
Yeah, user ID. Then it will contain all the images.
Then
profiles.
timestamp. Then
Yeah.
what? Timestamp dot something.
Yeah, timestamp.jpg, timestamp.png.
So depending on the image, so would you have one path or depending on whatever extension it is, you'd have timestamp.jpg, timestamp.png, something like that.
Yeah.
Right. Which means that on S3/images/user ID, you would have all the photos uploaded by the user.
Yeah.
Like, right. Chala. So instead of timestamp, you can also use UUID and anything that you would want. Okay. Okay. Second question. Would you want to store this information in your database?
No.
No need of storing it on database. So then how
No.
will you render the interface where you will render all the past photos and user will mark one as active?
So actually what I think is like I'll have all the images like in the user in
How?
this folder.
Acha, so you will be making a list colon S3 to get all the images of a user.
Yeah. Yeah.
Much
And-
costlier. Okay, that's okay.
Okay. And for the active one, like I can just like if I have to delete a earlier one and I'll update the current timestamp. Like I can do like that
No,
also.
that's a very bad approach. Think about what kind of problems would you fall into. Okay, chalo. Any suggestion? Would you store this information in a separate database or not?
DP so that we can do soft deletes.
Correct. You might want to do soft deletes. It's always better to query your database versus making a list colon S3 under a path, because S3's response times are much higher as compared to your database, because S3 list call you'd make, let's say 1000 photos user uploaded, going through making list call on S3 versus storing it out, because obviously you would need that information in your database. These are the photos which are there, and you might just delete and basically manage it, and might be analytics, how many queries were made on this photo. Like think about analytics as a use case. How many times was this photo rendered? If you want to make that, you can do that sort of stuff. Okay. So upload photos. Second, managing in database. You'd need a database to hold entries. What would be your table called? Let's say your table is called photos. And photos you would have something called as photo ID. And then you might have a user ID. And you would have photo URL. Anything else is deleted.
Uploaded at.
Uploaded at. So some timestamp if you'd want to.
Is active.
Is active. Will you put it over here? Think about your design.
This should be more.
And we'll put it in the main database where we actually
side of
store the link. We have to store the URL in the profile table, right? Maybe we'll save it there instead of.
In profile, we will have the actual ID which is active, like profile table or some other table.
Correct.
Yeah.
You would not store this thing because one user, see, this is a very, basically this is a very subtle design problem at hand. So we by default would think that we would need is active column here, because like you would need to know which photo is active. The problem with that approach is, let's say user uploaded 1000 photos, had one of them active, and then wants to mark another one as active. So you would have to, because this is a place where you would need to have only one as active. So when you would mark some new photo as active, you would have to mark other one as is active false. So how will you find out which one is active for that user and then mark it as inactive and then mark other one as active? That's a very, you would have to translate it into this into 2 or 3 write queries and a couple of get calls. So better way to do it would be, you might want to have like user table or something, in which user table you would have ID, some email and stuff, and you would have photo ID. And this photo ID would point to here. And this will be the one because at any point of time, only one could be active. Correct. So now when you change, sorry, it's slower now. Mobile मर जाएगा ना. ठीक है. It's too slow. Temperature high हो गया. ठीक है. So now what would happen is if you have this kind of structure where you have separate table. So now when you change one photo from active to and make another one as active, you'd only be changing, only be updating this one row. Correct. So you don't really have to go back and mark is active as false in photos table, and then go to this view and then mark other one as active, so that a couple of get and a couple of updates gets changed and made better to. What has happened? So sorry for this. Am I connected to the right? Not sure what's gone wrong. Connected to the right Wi-Fi. Yes. I'll need to check. If this doesn't work, I'll just change my camera mode. Okay. So instead of finding which one was active before and marking it as inactive and then marking the new one as active, this is a better approach. Agreed. The one which is there with the photo ID which is here is the one which is active. So you can at any point of time change your active photo by just altering one entry in the database. Yeah, Anshuman?
Then we can also have user ID in users table, right?
Yeah, so this is user's ID, no?
No, the user's ID in the photos table.
This is user ID in the photos table.
Yeah, we can have that in the users table, right?
What
is
user ID is here, no? So this and this are same.
It's a foreign key.
It's a foreign key. This
okay.
This would point here.
Okay, this is a foreign key. Okay.
Yeah.
Okay.
Right. So this way, what would happen is your get query. So your get for Gravatar, like https://gravatar.com/arpit, or basically it would be some ID, which would be your user ID, would just query this database or this table, get the entry in order one time, and would get the photo ID. Right. And basically, you would have to render the photo. So your database lookups are much efficient here. Right. Marking one photo as active is much efficient here versus like marking others as inactive and then another one as active. Agreed? Yes?
Yes.
Okay. Now what's next problem? So now we have successfully rendered all the photographs of the user through photos table. We would be able to render the current active photo under IM now. Supposedly we would get like the current active photo in order one time through this, right? Because like in this, basically joining users table and photos table, you'd get the photo URL and you can use that to fetch it and do it, right? Now, what's the third challenge here? How will you render the photo in IMG tag? Because your IMG tag, so third would be rendering photo. Rendering IMG tag. So the way IMG tag would be written would be IMG src is equal to https://gravatar.com/arpit. This is what would be written in the IMG tag. Now, how will this IMG tag render? Because this is an API call, right? This has to translate into like this call should return image. How will you design that, or how will you build this?
Yeah, just redirect it to the photo URL.
How will you redirect it to the photo URL?
Sending a 403. Sorry.
IMG tag works on. Does IMG tag works on 301 redirects? To be honest, I'm not sure if IMG tag works on 301 redirects. Does it?
Not sure about that, but
I guess it would need an extension also, right?
No.
Does
IMG
it
tag does
work?
not really need extension.
Okay.
You can even call it. You can even pass an API call there. At
Yeah,
the end,
apparently
what
we
it would
can
do is
redirect.
it would make a get call. So the job is simple of IMG tag. Whatever is given in the SRC, it would just make a get call. Assume whatever the response it is getting is image data, and it would try to render it. This is exactly why IMG tag are very vulnerable. So if you give, so you can actually upload a JavaScript file as an image. So basically your JavaScript code as an image, and you can, sorry, if you have a file upload button which expects an image to be uploaded, and you upload a JavaScript file to it, and let's say that service has not applied any security checks, and that JavaScript file is uploaded. Now, if that file is then rendered onto other platform using IMG tag. So when IMG tag would do is, IMG tag, whatever the URL is given, it would fire a get on that. It would assume whatever it got, and it executes it. So executes it implies browser would when it gets the image data, the execution of image data is basically rendering that image, right? So here what it would do, if it got JavaScript wala thing, so it basically executes the JavaScript file, which is where it's cross-site scripting, the most common security vulnerable, most common basically cyber vulnerabilities, cross-site scripting. Read about that if you don't know how image tags are vulnerable to that. So with this thing, what IMG tag would do is it would make a get call on this, assume whatever is got is image data, and would try to render it. Right now, what would you do to render this g.com/arpit as image?
It seems like it works, but it is not recommended. The redirection works, but it's not.
Okay, but is okay. Nice, thanks for that. So for this thing, even a redirection would work, but let's assume that we don't follow redirection based approaches. So what would you do?
What we can do is, like, once this URL, once this is requested, we can get a get call, and then on the response of get call, you can call another. Like, once you receive a response, you can call another get call.
IMG will not make 2 HTTP calls. IMG would make just 1 HTTP call.
No. Like, okay. So I like in Redux, right? Like, once you call a system, and then once the output is there, you can call another one, like, and then like it can be a sort of like one thing is executed, and on the response of it, you can also dispatch another call. And then once both
IMG tag would not work that way, na? That's the thing. See, IMG tag would just make a get call and expect it gets image data in return. So what would you do, or what should be done here is similar to what we discussed yesterday about on-demand image optimization service. Use that. We already discussed a solution yesterday for this very problem. So what would you do is this, like https://g.com/arpit. This will be an API call. This would go to your API server, right? So when client is making this call, this calls come to our API server. So this API call would come here. It would get the user ID from it, right? So when you'll get API, or basically when you get request for this, it comes to an API server. It will not go to CDN or someplace. It will come to your API server. Once it comes to your API server, you would do get user data, or rather what you would do is you'd get active photo of user by joining user and photo, correct? This table, this one. So what are you getting in API call is user ID, right? g.com/arpit. Arpit is nothing but a user ID. So you'll basically fire a query where you will join users table and photos table on photo ID that you have, right? So the photo ID that you have will be the active photo. So from photo ID, you'll get photo URL. This photo URL would be nothing but the path of your S3 thing. And once you get the photo URL, you would get, or you would read the object from S3. Exact image object from S3 in bytes, raw bytes. And then third, send this raw bytes as HTTP response. So what you are doing is you are doing content disposition through API URL, similar to how your normal static file servers would do. You would be doing exactly that. So typically this API is acting as a static file server with some dynamic parameters. So if this was a PDF file streaming thing, how would you stream PDF file through HTTP API calls? How would you stream images through HTTP API calls? This is how you do it. So when you get a request, you would make a call to S3, read the entire file of, depending on what your active photo is for that path, read the content from the file, from the S3 file, and dispose it as raw HTTP response. Just like how normal file would be disposed through a static file server. Very simple. So just send those raw bytes. Don't send JSON and all. Just send those raw files. So typically image data also accepts base 64 stuff. So just send it base 64 encoded bytes of images, and your image would be rendered like normally on the browser. Yeah, Anshuman?
Yeah, I just had that same question. What is this raw byte? So it will be the same base encoded 64
Base
format.
64, exactly,
right?
because your browser understands base 64.
Right.
So
right.
image
Okay.
can be streamed back and forth on base 64 encoded stuff. Do that.
Right. Right. Okay.
So the CDNs
Yeah,
will
so
still
JSON
be
is
able
not
to.
needed basically. Yeah.
Yeah, exactly. So here now comes the part of CDN, right? So if you see, like now the challenge comes in where the API call that is made would be https://g.com/arpit, and every time if our API servers are taking this hit, so every time whenever this profile is loaded, it goes to your S3, gets the byte, sends it back to the browser, and the browser renders it. This would create a problem where your API servers are becoming very bulky. You could, and since this is not very frequently changing, you can actually change something around it. You can cache stuff out. So you can use a normal cache here. You can use Redis, you can use disk storage, you can just cache your image data as a base 64 thing on any of the caching strategy which we discussed. Let's not use CDN for now, because CDN fetching from CDN is obviously not an idea, because this API, you can cache it on CDN as well. You can cache this thing on CDN as well. How would you do it? So when you're using CDN, you can configure any backend. So g.com/arpit on CDN. Acha, by the, how many of you know that CDN pe you can also serve JSON responses through CDN? Except for Akamai folks. How many of you know it? Yes, no? तो मैं उतना डेप्थ में जाता हूँ. ठीक है, चलो, I'll go into this. So what CDN typically does is, when you are configuring a CDN, so CDN is nothing but a distributed set of edge servers. So you have this world, you have some distributed set of edge servers spread around the globe, and depending on where your users lie, the request would go to the closest edge server, right? When you're configuring the CDN, so when you're configuring the CDN, what you give is, you give a URL to it. So URL is, you will give it a custom domain. For example, let's say we call this thing Gravatar. So let's say we do Gravatar, or basically gravatar.com as my CDN URL, or rather, let me give it a different name. Let's say I call this thing GCDN, gcdn.net. Okay, and then when I'm configuring CDN, this is the base URL of my CDN, right? So any request that would be gcdn.net would go to the edge servers of my CDN, which means these servers. Now, when I'm configuring it, I have to give it a backend, which means this could be something like https://api.gravatar.com. Okay, this is just an example, right? So I can give it gcdn.net to point to api.gravatar.com. So typically, camera path, let me just change my integrated camera. Might be a little sad, but yeah, it's better than it getting stuck. Okay. So here what we will do is our backend is configured on api.gravatar.com. So gcdn.net. So any request that comes on gcdn.net will be forwarded to https://api.gravatar.com, which means instead of so similar to this api.gravatar.com, you can also configure g.com, the one that we took as an example, right? So if I have this, and let's say someone hits, okay, sorry, before that, let's jump into this. See how it would work. So now let's say someone made a request for gcdn.net/arpit, right? Let's say the request that was fired was gcdn.net/arpit. Now what would happen is this request would go to what? Your edge servers, because it is here, because this URL is configured as part of your CDN. So the request would go to the edge server. So one of these servers, it would see, does it have the cached content for /arpit? For the first request, it would not have those, it would not have that content. Now what would it do? It would see what's the configured backend. The configured backend is https://api.gravatar.com. So it would forward this thing to get the data from the source. So the configured source is HTTPS. So this would get translated into https://api.gravatar.com/arpit. Now this, when your CDN will fire this will not be fired from the client. This will be fired from CDN. When your CDN would fire this, it would get some response. Now what would be this response? As we discussed, this would be base64 image data, right? So this is nothing but your image data. Once your CDN gets this response from your API server on your CDN thing, your CDN will cache this stuff, because that's what CDN do, right? CDN will cache it depending on what you are configured. Once it caches the information, it would send the response to the one who has made this call, which is your IMG tag. Right. So next time when someone makes the same call, gcdn.net/arpit, it would get data from the CDN and not make backend API calls. Right. And now let's say if user changed the active photo, you'd go ahead and manually purge the cache of CDN for that key, which is /arpit. Clear? Samjha? Nahi samjha?
Yeah, so manually purging cache from all servers across the globe, would it be?
No. Basically, typically this is
so I just fire up a request and CDN does it automatically.
Yeah. So basically, this is the job of the CDN to implement this stuff. So you can explicitly go ahead and purge it for a key. Here the key is your user ID. So when you do it, it will go ahead and purge it. So whenever next time the request comes in, it would not see any cached response. So it would hit your backend API server, get the response, cache it, and then send it.
Okay.
Hey, can you go to the previous slide, the step 3, right? So that thing here, you said the raw bytes. Now you can actually even set the right content type here, right? Because you know the underlying URL, whether it's JPEG or so you can set that when you send that back. So the browser will know the. Okay.
Yeah. You can do that. So this is just about basically laying that foundation on how to utilize this was question which I never ever discussed. Like, but it's fun. See, basically that's why I love this live classes. Like out of the blue, we just picked up Gravatar and designed it. Chalo. Okay, was this useful so that I can add it to future codes if I want? Yes, no?
Yes.
Yes, no? Chalo. At least all of you got now what and obviously this is not just for image. So CDN would just treat any backend, any response that it got from the backend, it would cache it. You can do a JSON caching as well. Like to gain performance out of it, you can cache JSON responses as well. Let's say your profile information of a user is typically static. You can cache it on CDN side, and from that you can like directly serve the content. And then once it expires, it would make a call. So you can use CDN as a cache for your HTTP responses, like a normal JSON responses as well. Here we have used it for the most typical case, which is like caching image data, but you can also cache JSON responses here. Chalo. Yeah, Pradman?
So purging the cache would across CDN, this would have some time limit, right? Across geolocation.
वो थोड़ा सा time लेता है, हाँ.
मतलब this we can at least handle like.
Yes. And obviously, changing active photo won't be that frequent. Like it's a once a day activity at max.
Yeah.
Right. So that is still okay on the CDN side. And even if you scale it to 1 million users, it won't be that big of a stuff. So CloudFront, Akamai, all of the providers give this API to purge a cache for a key. Here the key would be /user ID. You'd be purging the cache on that.
And also like based on kitna paisa doge, they kind of have a tier, fast purge and those things. Like within 5 seconds it will be purged and like
ये correct. ये ध्यान से निकल गया था. Correct. So they make money out of it. So they give you multiple tiers as offering. कि भाई, we would purge your cache this quickly. So paisa do. हाँ. Yeah, Rana?
Arpit, in this design, we are assuming that we won't need a timestamp on which, like, if you comes in or I come in. So my last photo was this from this to this. So if we would have
the last photo is basically the active photo which is configured by the user. We just made things a little interesting, where a user can choose which photo to be rendered across the platforms, across all the platforms in the world. Like, so people who are using Gravatar, you can just use it at any place. Like a great implementation of this is, let's say you have like 5-6 different websites on which you can embed photo URLs of yours. Like just add this Gravatar URL at all the places. Now, by logging into gravatar.com and just changing your active photo, you would be changing profile photo at all of the places. It just, but basically without even altering the source code of that.
Right, but if the use case like was little bit different, that we have to maintain an timestamp from which to which it was active, like we would have done it via one table only, like sort of SCDP.
So basically in that case, the active photo, if you would always want to have like the most recent photo as the active photo, then you would not need the last table. You would not need this table. Like you can typically do it like fire a query on this, order by timestamp, descending bay, and just pick the first one.
Yes. Okay.
Yeah, Varun?
Yeah, I have a small question in the last part of the CDN. So when the client receives the response, so the image tag obviously cannot render the base 64 image, right?
It can.
I mean, directly without giving any hint.
Yes, it can. It can. You just have to set the right headers. Then it can. So in the HTTP response that you send now, you just have to set the right headers, and then you can actually render base 64 images.
Oh, thank you.
So it's stream/octet something. If you set that part and start it with base 64, x hyphen base 64 plus something, and then you give it the data, it can render that. Yeah, Anshuman?
Yeah, I was wondering about this A record and CNAME records and how will they be published. So all this will be taken care by the CDN, right? Everything.
Why would you need to worry about A record, C record for this use case?
So if you see api.gravatar.com should redirect to my my API server, right? So that it will.
It would be normal. So this is exactly same as like, so hitting gcdn.net/Arpit is exactly same as hitting https://api.gravatar.com/Arpit. It's exactly the same. So both are public URL. It's just that if someone hits gcdn.net, it would be cached on CDN. If someone hits api.gravatar.com/Arpit, it would always go to your API server and then get the data.
And like from what I have seen on the implementation, like the forward servers or the forward host names which are used, they kind of have a whitelist of which domains can like contact them. Basically, only the IPs of the edge CDNs can contact them, and no, they'll kind of return 5.
You can optionally whitelist some set of IPs, but you can also keep it open. Like there are so many services that keep all of these things open, like their API servers URL. But they also cache it through CDN optionally. So at least anyone hitting their clients or anyone coming from the clients who has like their CDN endpoints and all, that would work faster. But if someone would directly want to hit their API servers or the true backends, they can still do it. But yeah, that's a choice that you can make. Chalo.
Okay, so yeah, so then it means that no such things will have to be done, right? No records need to be. They're all public APIs, yeah.
All public.
Okay. Yeah.
Chalo. Sir, out of the blue, a new question got covered. I'll add it to the list. Interesting design. Ha! Finally, social networks. We already patch हो गए ना? एक मिनट रुको. Can I take a simpler one first then? अच्छा ठीक है. Let me just basically shuffle the order a little bit so that we can take a break and then complete the other part. So before we jump onto and after the break, we will start with the user affinity table and reactions. So let's see how would you implement tagging of people. So Facebook, Instagram, every single social network has this feature where you can tag people in the photo. Like in a photo, if I have 5 people, I can tag each one of them with a person. Like if you were to implement this, how would you do it? Let's brainstorm. Suggestions? How will you implement this part?
This is just for photo or like on the comment?
Only on photo. Only on photo. Tagging people on photos. How will you store this information? How will you render this information?
You can denormalize it inside the object post itself, right? Those user IDs that are tagged.
Maybe use the Cassandra that we already set up yesterday.
No, but chalo, let's start from. So let's start from how will you display the tags? So you have a photo being there, right? So now what would you want to do is you want to show like you would need an ability to find the position at which someone exists and then you tag it at that place, right? So this position some person, this position some person, this position some person, right? How will you store this information?
Coordinates of image.
So image coordinate, let's say the resolution of this image is 1024 cross 768. So what would you store? And I have 3 tags. How will you store this information?
Pixel distance from the first corner, like
X and Y coordinates, right?
So the way you'd store this information, let's say it's denormalized, let's say it's JSON. How will you have this information?
X and Y.
Okay. Yeah, X and Y. Let me come to the X pe what would you store? Let's say I'm talking about this. What would you store in X? Let's say something 60. Let's say this distance is 60.
Yeah.
And then this is Y. Let's say this distance is 10. So you'd store Y equal to 10. Correct. And then you would also store what? Who was tagged? Say user ID. Correct?
Correct.
Any problem with this approach?
We may store percentage instead of absolute values as well. Like percentage of distance from left, like 30%. What if there are different image sizes that are being stored? Then absolute value may.
But if that image ka resolution, but so different image sizes being stored, matlab for the same image, multiple image sizes.
Yeah, I'm just thinking if it can be the problem.
Can we just divide this into smaller rectangles and then assign? It'll be simpler to encode that
That's
data.
over engineering, man. Over engineering. So yeah, typically there are bounding boxes. Like where you identify faces, you would have seen that basically faces ka jo there comes a nice popped rectangle and stuff. So that's a bounding box. Here the bounding box is just a pointer. So Anshul, can you think of this use case as a genuine problem?
Yeah, when we were trying to serve image with the lower quality for lower bandwidth people. So this
Right.
can be
So
used.
in that case, exactly something that we discussed yesterday, right? Image optimization. So when we serve the low resolution images, 1024 cross 768 can translate into 512.35 something, 356, 359 something. Right? You might just halve it down. And then 6010 won't look good, right? Because 6010 would go like here in that case. Correct. So instead, so this is what the crux is. Instead of using absolute pixel coordinates, right? Always go for a relative one. So the way Anshul was putting it was percentage, like do that, but instead of storing percentage, keep the ratio, like something around this. So tagging people in photos, when we talk about this, the coordinates has to be normalized in the ratio of 1 is, in the ratio जो है वो 0 to 1 के range में. So for example, this coordinate right here could be 0.8 because it's 0.8 of x and then 0.7 of y. Right, so that even if you optimize the image, lower the resolution, do anything around it, your position of tag won't change. It won't change with respect to device resolution. It won't change with respect to image optimization technique that we applied. Right, so this is what the crux is. Storing is not a problem, but yeah, this is where you'd have to think about it, what might actually come in. So great job, Anshul. It's just that you would have to converge upon the right word, which is normalization, and then storing it in the ratio. So basically, percentage was a good choice, but a better would have been like do this. And obviously you would have something similar in mind, but just using the right term would have made the difference. Right. So depending on so it makes things very agnostic of resolution or optimization or format and whatnot, right? If you just store it this way, right? Now just extending this problem to a bounding box, right? So Facebook Pay, when you tag someone, it actually identifies a square around it. So if you have like someone being, if this is the photo on Facebook and someone has this big of a photo, something like this, right? So the bounding box that Facebook would show would be this big. If this photo was smaller and has 3 or 4 people, let's say another person is only this big, then the bounding box would be this, right? So this, how does this bounding box information get stored? Instead of storing X and Y, it stores X and Y, and it would store the width and the height in relative measures. So either top left and bottom right coordinate would also do the job if it is always rectangle. If it is always rectangle, then instead of storing X and Y, it would store X1, Y1 and X2, Y2. So this would become X1, Y1, and this would become X2, Y2. And it will always be a rectangle that would be stored. This technique is very heavily used in data science as well. Whenever you see image being tagged and YOLO algorithm and whatnot, where you see the bounding boxes and object detection in place, they are always rectangular. And when they are rectangular, the kind of information you would get, it would either be top left and bottom right coordinates, or top left coordinates with width and height. Right. So through this, you can define bounding box. So here there are 2 approaches to do it: X1, Y1, X2, Y2, or X1, Y1, width and height. So instead of storing absolute, this could also be relative. Right. And basically, this is what the crux is. Otherwise, storage and all is like very simple. Like you can store it in normalized, like NoSQL and all. That's something that we already discussed. Like how would you store this information? But the thing that is most interesting over here is to like denormalize and store it Along with this, how would you handle bounding boxes? Something like this. Clear? Yes. No. Okay. Chalo. Chalo. It's 5:02. I just went a little here and there just because, like, break to leni hai. So let's take a quick break till 5:10. We had a very interesting detour, like Gravita discuss ho gaya. But yeah, we will definitely be covering what was planned. So don't worry about that. We'll definitely be covering. So once we return, we'll be covering user affinity. Basically, how would we store following relationships? Like if A follows B on Instagram, on Twitter, and whatnot, how will you store this kind of information efficiently and at scale? This is something that we would talk about. And apart from this, what else is planned is apart from this, we would be covering we would be covering a very interesting feature called newly unread indicator. Like on LinkedIn and all, and even Instagram, you receive a message, it shows you like you received 3 messages, but even you did not mark those messages read and you just open it once, it vanishes. Right? We would build that behavior. Right. So this is these are the 2 topics that I plan to cover after we come from the break. So let's take a break till 5:15. No, sorry, 5:10, and then we'll start with designing of user affinity. Okay. Sure. Thanks, guys. I'll start. They're a nice speaker. So we'll jump into the next part. Let's build user affinity, follow, unfollow sort of thing. So what's follow, unfollow is, you in Twitter, Instagram, LinkedIn, like in LinkedIn, you can connect with people, Instagram, you can follow people, Twitter, you can follow and follow back and whatnot. So this sort of thing. So the way you would want to design this is something that we discussed yesterday in the DB design. Like a very simple DB design would be like when a user follows another one, we create a table called relations. Let's say user affinity something. In this one, what we do is we have a from user ID and a to user ID, and then you might have a soft delete and other options. So from user ID and to user ID, you'd know that, like, let's say Arpit, or let's say Arpit followed Virat. So from user ID would be my user ID and to user ID would be Virat's user ID. And this new row would be inserted in the table, which would say that A followed B. So when user unfollows this, the soft delete comes into the picture. So when you unfollow someone, instead of deleting the row, it is always better to do soft delete. Again, the reasons are something that we discussed, like you would always want to do batch cleanup, or maybe you would want to, you would want to restore the links and do something fancy with that. You can do that. So from and to have a soft delete and then do a batch delete if needed to make batch writes on the database and improve database performance. So you might want to have a cleanup service that would, once a while go ahead and clean up the rows which are marked as true with is deleted as true. Now my question is, why did we name, just about naming, why did we name the table relations and not follows? Like why would you take this call? Any guesses here?
Relation can be of different type, like in future we can have friend instead of follows, or a new type of relation. It will be easy to extend using this table.
Exactly. So just basically keeping things in mind for the future. Like I do have following. Let's say Instagram also added this thing called close groups or close friends. Yes, no. Let's say you implement something like very interesting. Let's say Instagram adds a new thing called crush, right? And you can, apart from follow, you can also add that person as crush, and it might, show his or her updates in at first to you, right? So as soon as the update is made, stories published and whatnot, you'll immediately get a notification for that. So extension is something that you should always keep in mind when you are designing such things. So you don't have to make it over engineered. So if you see, this decision was just about naming something, and it had nothing to do with, our design, or we are making some drastic design decisions around this. It's just a very simple thing, but just allowing us to, not alter a lot of code, because if you name it very specific. So I typically give a very nice example around this. Like for example, there is this company called Make My Trip. We all might have booked tickets from it. But now if Make My Trip wants to venture into something very different, it won't go with the name, because the name says Make My Trip. It has to do with trips and travel and all, right? But take another example, Paytm. Paytm started as a wallet, now then became an e-commerce, UPI, bank and whatnot, flight booking, train booking. So because the name was generic, right? For example, Swiggy. So Swiggy is such a generic name that it could add any sort of feature into it. Maybe everything related to food, because it would not want to venture, but then adding, allowing, because name should not be something that would make things a little dizzy for the reader. Like especially when we name something like this in the database, if it is very common, or if it is very specific. Like another classical case of this is like infrastructure site pay. Whenever we spin up a new database, we give it a name depending on the use case it is going to serve. The problem with that is, let's say I have a service called Bookmark, and I've created a new database to store Bookmark, and I was expecting quite a bit of traffic on that, but I did not receive it. So now what I would do is I would want to piggyback other services to use the same database, because like I have this overprovision, why to create another database? Let me piggyback. So now let's say I piggyback another service on that database. But now that service owner would have to say, ki, "Arey, my service is on Bookmarks DB." It would be really weird to, you know, explicitly make this conscious effort to think, ki, okay, this is what it is. This is the name, although it does not sound good, or it does not resonate with my use case, but still I would have to live with this. And worst would be the low-level code would have to live with this. Like you would have like follows table make close friends and follows table make crush, you know, all sorts of things. So always keep in mind to go one level abstract if possible. If it does not take a lot of effort, go a step abstract. It would help you make things extensible for your future changes, like accommodate any sort of things that you would want to. So through this, you can like add new columns to it, like from and to. Let's say Arpit and Virat, to take an example, is related was there. And then you have is follows, is close, is crush, all of those things as separate columns. It makes things very easy for you to extend. Let's say if you want to add one more relation to it or another feature to it, like add one more column to it. Like depending on it would be true, false, true, false, true, false. Right. But if you see like although we had is related, it seems redundant. So you can get rid of it, replace it with another value, Boolean ke jagah, you can take integers, or always keep on deleting entries. There are multiple ways to handle it. That's why I just added is redundant, because there are multiple ways to design it. You should always be open about like how would you design soft deletes. If you not want to do soft deletes, what other approaches can you take? Right. So one thing where this approach would fail is like, let's say this from versus to table has a growth potential of n square, where n is your maximum number of users, because theoretically every user can follow every other user, so it can go up to n square. Now given this thing, when you are creating, or once this table grows big, adding a new column might become a challenge, right? So this design is something that is not scalable with time, but it would work well when you are just trying to figure things out for your product. So this is more like a day zero design versus day end design. But this is a design that is meant for day zero, but could sustain day one as well, right? But it would definitely not work at scale. Another place where it would falter is when you would want to implement groups. Let's say you are allowed to create custom groups on the platform, right? This is not how you would implement it. So that requires a very different kind of database design to how you would handle groups. So implementing custom groups become difficult, and adding new relation would require you to run a new column, which means alter table, which is one of the most expensive things at scale. So you would typically avoid alter table commands during your peak hours, and even during VRs if it's high enough. So implementing groups requires a different thing. So now, how would we scale? Obviously, now the question comes, like I do have, like I'm Twitter, I exploded, I did get viral growth, and I want to scale this thing. So how would you implement following relationships? So having such a massive scale is a big worry. But can we use graph databases for this? You know, graph database seems like a very, you know, it seems like a very innate choice, a very obvious choice. Like I have two nodes, like users nodes, A and B, and I have a follow relationship. And let's say B follows back A, I would have another edge from B to A where it says that, okay, because my follow is unidirectional, it's not bidirectional. Like LinkedIn Connect is a bidirectional action, but Instagram follow is a unidirectional action. Right, so graph database seems like a very obvious choice, and this is exactly what Twitter did in 2010. So now, graph data structure looks like an obvious choice, but in the year 2010, graph databases were not popular as they're popular today. For example, Neo4j, then Badger, dgraph, and all of these databases, these were not there at that time. Or Neo4j was not that famous. I don't think it existed back then. But like 2010, when Twitter saw viral growth, they had to come up with a solution. So which is where they created something called as FlockDB. You can find it source code in github.com/twitter-archive/blockdb. It's a very simple source code. We will go through the design. It's more about like we understanding that if we want to hack our way through SQL World into building graph database, how would we do it? Like yet another design pattern to keep in mind. So in the year 2010, when they had to be scrappy but innovative, what did they do? They implemented something called as BlockDB. It's a graph database built on top of MySQL. It is optimized for large adjacency lists, fast reads and writes, pagination, and arithmetic queries. Like think about Twitter. Like you would need to have large adjacency list because one person can follow a million people or a person can have a million followers, right? So it needs large adjacency list. It has to be fast read writes because these actions cannot be slow. Like you cannot go through like writing 3-4 places into one transaction and then do that. This has to be read fast because it will be called every time. Because whenever your feed is rendered or a post is rendered, you would need to fetch that if this user follows this another user or not. Otherwise, you would show that follow button or unfollow button depending on that. So the read, it has to be read heavy and fast, write heavy as well. The pagination has to be equally fast because like when someone is scrolling through all the lists that he or she of his or her followers, it has to scroll to all of them. And similar to the one that we discussed the last time about scrolling becoming slow after a certain amount of pages being scrolled, typically 10,000, the one that we shown graph about MongoDB and all, that same problem would kick in. Like this should give equivalent performance at any page because people like to scroll and go through all the followers that they have. And this was a very common use case, and not just from user's perspective, but also another perspective that where you would want to broadcast notification to all the followers of yours. If you'd want to do that, right? This is where you would have to go through all the followers of a person. So that is where pagination had to be fast. And arithmetic queries, because you want to very quickly render the follower and following count on the web page. So arithmetic has to be fast, pagination has to be fast, read write has to be fast, everything has to be fast for this. So, but what did they not have to worry about was graph traversals, right? Because unlike LinkedIn showed like you are 2 degrees away from this other person. Twitter never shows you that. Twitter does not want to solve graph traversals to this, right? So why I'm spending this much time into this? Because if we know the constraints or like non-optional thing and optional thing, we can make some really great design decisions, right? So this is what we'll see on how Twitter did this with BlockDB. So what did we do? So what did they do? Like they did this. So this is something which is taken from the source code of BlockDB. I went through their announcement and then went through the source code and then basically took this part, right? So what they did was they stored the graph as a set of edges because in SQL table you just have rows and columns. In that only you have to be scrappy and innovative. So what did they do? Like source ID, destination ID, a position. So this position is nothing but your sorting criteria, right? So let's say if you'd want to render the feed such that most recent follower first, the position would be the timestamp at which the entry was created. So position is a very generic word which they use to, to do the sorting and stuff. So it will be an integer value on which sorting would happen. And then they had a state, which was like positive, negative, archived, some meta information to hold with that. So they did this very interesting thing. So they created just 2 index on that. First is primary key. Primary key was created on not just on source ID or source and destination combination. The primary key was created on source ID, state, and position. They did not have destination ID that they did not have destination ID in primary key, right? So in primary key, it was source ID, state, and position because primary key is clustered index. So they would want to keep the entire information intact and source ID, state, position, and unique index on source and destination ID. So unique index on source and destination ID would allow to not have redundant entries in the system for a certain combination, but the primary key depend on which the clustering would happen because primary key is stored as clustered. they would leverage a lot of data or a lot of behavior out of it. By having a primary key on source ID, state and position, they could have very well done primary key on like source ID comma destination ID. But instead they went with source ID, state and position, because that is how their queries would go like, right? We'll come to it like how wonderful that solution is, right? So here, obviously one MySQL node would not do the job. So they partitioned it. They partitioned the data by node. Node is user in this case. So each user's data would be there stored in just one node, right? So any query would not require a cross partition execution, right? So for me, like all of my followers following wala part would they be there in one database. For you, it would be there in that other database on which you are sharded or you are partitioned to. So this is a very interesting ploy that they plot. But if you see, the problem with this is that if I'm following someone, if I want to store follow-following relationship, it's bi-directional. I'm following someone, so I would want to know who followed me and whom am I following. So how did they solve it? We will come to it. This is a very interesting ploy that they would have to solve. Now comes the pagination part, which they have to tackle, because any page of the result has to be equally fast, because to broadcast notifications to all user, going through the followers list and adding it to their corresponding feeds, there are a ton of use cases which you would have to do on the following relationship for a user. So that's why pagination is done by the position and not by limit offset. So through that position, it would do like something similar that we saw last time. Like I've read till this position, give me the next one. I've read till this position, give me this next one. And this position is nothing but a relevance score, you can say. Like higher the score, higher will be the position of the result in this thing. So it would always go by that. And bidirectional relationships would be two edges, like who follows me and who do I follow. So when you want to store so every entry that you make, like I'll do this, like this is where the magic is. Like this is mind-blowing thing. So what would happen is, like if you think about it, how would you store A follows B? You would store it as just one row, right? A follows B. So from ID to ID. So source ID, destination ID, A follows B. But what it also does is, instead of storing just A follows B, the unidirectional relationship, maybe they store two entries in the database. Like A follows B and B is followed by A. They store two entries even for a unidirectional relationship. This is gold, because what this allows us or them to do was the data for the source node. Here the source node is what? Here the source ID is this. The data for this would reside in this one partition only, right? So like A ka data would be there in just one partition. So A follows B. If I were to find out who are my followers, I would just go to this partition and get the data. Correct? So the partition of A, and I get the data in one shot. Correct? Now let's say if I want to do like who am I followed by, right? So that information is also being stored here. Like B is followed by A. Similar to that, like A is followed by B, C, D, E, and F. Like people who are following me. This also gets stored along with the A's information there only. So here, this two information would be stored on two different data, but there would be two rows created even for unidirectional information. So A follows B and B is followed by A. This way, Twitter makes two entries for each follow. So if there is a follow back, let's say A follows B and B follows A, which means there would be four entries. One for A follows B, B is followed by A, then B follows A, and A is followed by B. So there would be four entries around that. So this way, I would be efficiently be able to answer people I follow and people following me in equally the same time by going through that one database only. Yeah, Rahul.
I'm a bit confused. So you mentioned B followed by A, like how it's entered in database. It's just like
the same thing, Source ID, destination ID, no? The same thing, source ID, destination ID.
So it won't be like a duplicate. Like how do we know like B is followed by A? It'll be like the same thing. B followed A.
No, B is followed by is different than A follows B.
Like
Let's take a use case around this. Okay, what would happen if I have this? So if I have my database like this, so here would be my source, here would be my destination. Okay, and let's say I give a call relation or something. Okay, so now what would I have is I would have like A follows B. Correct. And now what would I have another row as B is my source, and B A, and it is followed by. Okay. Now given this thing, if my data is sharded, okay, if my and obviously my sharding would happen on what? Source ID. So typically these two rows could lie on two different databases. Correct? Once these two rows lie onto two different databases, now see the kind of queries that I can answer. Now, if I want to find out whom do A follow, right? I can answer it through this table.
Yeah.
Right? I would go through any where my relation is follows, right? And I would see where source ID is A. Like see on Twitter, if I take example, you have two tabs, right? You have one tab called followers and you have tab called followings. Correct? Followers means people who are following you. These are people who follow you. Now, if I don't make this another entry, okay, now how would I query this part? So, okay, let's just complete this now. Followings. So people I follow. So people I follow. Now let's try to answer the first one. People who follow you. How will you answer people who follow you from this table? Source, destination, and relation. Batao.
By the relation.
So basically, what would be your SQL query here?
Where relationship is followed. Select.
So here the relationship is always follows, na?
Yeah.
So what would you query? Select star from table where
Source is A and relationship is follows.
Where source is A. This is what you can do. Correct. Now, if I want to query on following people I follow, what would be a SQL query for this?
Sorry, come again. I missed you.
Right. So for the other case, people I follow, what would be your query for this? People I follow.
So where destination is.
Oh, sorry. Ulta ho gaya na? Ulta ho gaya. So for the following, so people I follow would be where source is A. Yeah, here. So people I follow is basically where source is A. Correct?
Yeah.
And people who follow you means where destination is A.
Yeah, destination.
Right? Which means you would have to create indexes on source as well as on destination. Correct?
Yeah, I get. And one more thing you mentioned, it will be in the same shard. But what if I follow like a guy after like 1 month? That will go in another shard, right?
No, so the sharding is not time based, no? It is based on source ID.
Okay, sorry.
So for a certain user, all the data has to be in one place.
Okay.
See, okay. So now with this approach, okay, this is gold, guys. Just give a good attention here. So followers implies where destination is A and following implies where source is A. Now, with this, what we would have to do is we would need an index on destination column as well. Correct? And in second case, we would need index on source. So basically to answer the second query, we would need index on source. Okay. So given this thing, how will you partition the data such that you would get answer to both of these queries by making a query on just one database? Can you do that? Can you answer this query like where destination is A and where source is A, both of this query, because partitioning, because how will you partition the data? Let's say you have exploded, one MySQL cannot hold this gigantic table, so you are partitioning it. How will you partition the data? So let's first start with partitioning and then we will address this situation. Chalo, how will you partition the data?
Based on the followers. Like,
Based on,
I mean, there, like, if there are, I mean, if a person is not so popular, they all will be
let's
subcategory.
treat every user equally. Let's say every user is equal. Let's not worry about popular, not popular, because
Yeah,
that is not a
then user ID, sort of.
Which source or
ID of the
destination?
user.
On the basis of source.
Source ID, right? So
yeah.
at scale, you have partitioned your data by source. Correct. So then how will you answer this query? Where destination is A?
Hey,
yeah.
Hey, Arpit, just one question. Since this is a sharded data, basically I'm going to keep data for the user on one partition. So all I need is really the connection, the outward or inward connection, meaning to whom that guy is connected and what is the kind of relationship. So actually I just need two columns in that table, conceptual table, that the other user and what's the direction, incoming or outgoing, right?
Yeah. So source to destination, basically. So now that data is partitioned by source, right? How will you answer the first query? Because when you're making a query where destination is A, this is where the interesting thing comes in, because you have not partitioned the data by destination anywhere, which means the query for destination A could be present on every single of your sharded database. Correct? Yes, no?
Yeah, so basically cross shard joins.
Cross shard connections ho gaye na? To answer this query, to answer where destination is equal to A. See, you have partitioned the data by source. So partition the data by source. This would very easily be done because where source is A, because this is what our query is, where source is equal to A. And if you have partitioned by source, which means when source is A, it would be present in one chart, source is B, it would be present in another chart. So your query would go to just one database and it will have all the answer it needs. Right now, for answering the first one where you want to render followers, right? So people who follow you, like where destination is A. To answer this thing, you typically have to visit every shard and find where destination is A, because all the data where destination is A is not present in one database. Yeah, Rajendra?
But in that case, wouldn't we, when somebody starts following somebody else, wouldn't we make two entries? Meaning, I make an entry for that user and say that he has started following this, and then I actually use the shard for the other partition for the other guy to whom he's following, and
exactly. That is exactly what Twitter did. See, basically, that is exactly what Twitter did. So, which is what I was covering. Like, instead of storing one entry where A follows B, it also stores B is followed by A. And we are just coming to the justification on why is that a good idea. Instead of storing one entry, basically you are actually very right into actually pointing this out. And this is where the crux is. This is where Twitter acted really smart into tackling this problem, where instead of creating one entry, they created two entries for the same thing. And this solves the problem for that. Like, this is what we are coming to.
I mean, even if you have to make two entries, the alternative to this is like hitting 10,000 different shards for a single query.
For a single query, exactly.
So like the two is a much lesser evil at this point.
Exactly. So although it would seem like creating two entries is like basically doubling your disk space, but it's much better than querying 10 shards to get just your followers list, because this is a very common action where I would want to get followers that I have, like all the followers that I have. And for that, I would have to make query on where destination is A. And for that, I have to visit every single shard and then ordering. How would I order? right? So then depending on where my query is going, I'd be ordering it in, I'd be getting result in some random order and all, right? So this is where the problem was. So that is why if we create another entry where we say that we add relation here and we say follows, and then we create another entry where B is the source, destination is A, and we say followed by. Okay, so B is followed by A. So basically active voice and passive voice. Dono handle kiya. So B is followed by A. So the entry of B would go into a different shard for the, so basically row 1 and row 2, let's say example. So row 1 will lie into one shard, row 2 will lie into another shard, right? But there we get where destination is A, wala thing. So where you would just do the ulta query, right? And just store the reverse mapping as well. So B, A followed by. So there also you will make query like where source is equal to A, but relation is followed by. So A is followed by whom will give you the followers of it. Correct. So now at scale, what would, when you have this thing, you would have, you just have this thing. So your queries would change like where source is A and relation is followed by. Basically followers aayenge. And then for the second one, it would be where source is A and relation is follows. Got it? This way, if you see the query, both the query just acts on source and has nothing to do with destination. So you're partitioning, when you're partitioning data by source, everything would still work because you would, your query about destination are still working seamlessly fine. Right? Because you have just done the active passive wala conversion and just added that check there. Clear? So we have typically translated our destination is A query into source is A query by just adding an extra bit of like relation where you're just defining it the ulta relation, like is followed by.
While writing, we always have to take care that, like, let's say I'm following you, and like when you are following me, then I have to read your shard and then write in my shard as well, right?
No, why would you want to do that? Why?
So let's say I have a shard, like one shard number 1 and shard number 2. So in shard number 1, I have written that I am following you because a shard number 1 is for me. And like, how would I check that you are also following me? So
why would you want to check that you are following me? This is followed by. See, the entry that we are making is A follows B and B is followed by A. Both are one and the same thing.
But for that, you have to check that are you actually following me or not? Like, how would you check that?
B is followed by A. See, एक मिनट. A and B are there. Okay. A is the logged in user. B is some celebrity. Okay. A hit the follow button on B.
Yes.
Correct. So then when we did this, so we create one entry where A for the we create the first entry called A follows B. Right. And we create another entry which says B is followed by A. Both means one and the same thing, right? You don't have to check because B is followed by A is same as A follows B.
But how would you check then that both are following each other? That you have
Why do you want to check that both are following each other? Why? B is followed by A same as A follows B. It's not bidirectional. It's still unidirectional.
Okay. But in lending connect,
let's say you and Virat. Let's take an example. You and Virat. Okay. So, I'm not getting who is speaking. Yeah, Ronak. Okay. So, what do we have? Let's just say. So I have. So let's say Ronak follows Virat. Okay. This is one entry.
Right.
But what does this also mean is Virat is followed by Ronak. Here, while making this entry, do you ever have to check if Virat is following you?
No. So in that case, in Twitter's case, you don't have to check, but in LinkedIn's case, like a request is there, and if one needs to know like both are mutually following each other, then we have to make another call.
So for that let's say, so now that would be a different entry, right? So in that case, let's say next day, let's say tomorrow Virat chooses to follow you. So when Virat will hit your follow button, what would you do? You would create an entry called Virat follows Ronak. And Ronak is followed by Virat. Correct. So when you both are following each other, there would be 4 entries in the database.
Yeah. And then if we want to check mutual exclusive, then we can query those 2 shards. Like
mutual exclusive of what?
Like if both are following each other, like mutual.
If you'd want to render that, you can check if the entry exists or not.
Yes.
But this way, your query would always happen on the source column. Yeah, and through this, the partitioning part becomes very simple, because so basically this trick is very neat, because we just converted our destination. We just discarded our requirement to be like we needed an index on destination, but you could partition on just one column. So this is a very interesting way where this active and passive conversion they used, and by creating redundant entries in the database, they got a very interesting performance benefit out of the normal MySQL database, and they are still using it in production, by the way. Block database ka variation.
The only thing is, if B is a celebrity here, then his shard will have a lot of entries.
Yeah, but that is okay. That is okay. But when he or she would also open his or her account, he would want to see all the followers that he has. So that is there. So hot shard problem would anyway be there with the celebrity accounts.
Yeah.
And that is okay, because then your data is typically sharded by, you would add one more shard to handle it. Then you would define the partitioning logic, the sharding logic, however you would want to do it. But still do that. Let's say having 10 celebrities in one shard might not be a good idea. So you would like manually assign partitions, like this celebrity should go there, this celebrity should go there. And that is why the blue tick mark happens to be a great product as well as engineering decision. Sure. Everyone understood this part? Because this is a really interesting. So being scrappy, being creative, and being smart is something that was like really amazing on the Twitter's part, where they didn't have the liberty to use graph databases because they were not that big at that time. So they scrapped their way through. They acted a little smart and they built a solution. It's like, and the code is very simple. Like FlockDB code is one of the simplest code and yet the most impactful code that you'll find on GitHub. It's really simple. The schema, how many shards would be there. It's a very simple code base. You can just go through it. FlockDB. Chalo. So now that we discussed about graph databases and all, if you see like similar to following part, we can also model reactions like A liked this tweet, B liked this tweet, B retweeted tweet T, like all of these things. So in most cases, when you are designing a social network, a lot of things can be modeled in graph database, right? But this does not mean that we should be modeling everything into graph database. So there have been attempts made by a lot of startups who have tried to model social networks as pure graph database and not needing any SQL storage whatsoever. So everything was graph. Facebook very popularly in the year 2011, 2012-ish, they introduced this graph query, not GraphQL, but you can query a knowledge graph. So you could query, so you could make complex query like people I am friends with, living in city this, aged this, working at this company, but not liking, let's say, Chinese food. right? So they had this very nice graph structure, this knowledge base, and you can query in this graph-like structure and get responses from it. But then Facebook soon realized people started abusing it, like, and then they basically shut that thing down. But Facebook tried to model everything into this graph and allowed us to make open queries on that system. So that was a great thing that Facebook did with the kind of rich data that it had. So that is something that you can leverage. So graph plays a very critical role in building recommendation system, right? When A likes B, sorry, let's say you and another person on Twitter like the same tweet, right? So then as part of recommendation engine, a tweet liked by other person, Twitter can recommend this tweet to you, right? Because you both would have a very higher affinity towards that, right? So these graph structures are very heavily used in recommendation engines. So always think about modeling it. So reactions, affinity, tags, a lot of things you can do this thing on graph, and you can model it on graph. Okay. Tagging photos we saw. Chala. Final thing around this, what we'll do is we'll implement newly unread indicator. So understand the problem statement very well. So what we are trying to do is, let's say we have this message notification, or basically the messages ka icon on Instagram or LinkedIn, whatever you'd want to pick. And let's say you received n messages when you were away. Once you received the messages, it's then you get this notification which shows the number of unread messages that you have, or number of newly received messages that you got. And then once you hit that, you open that page where you see all the messages. Then you are not supposed to go ahead and mark all of them as read, right? And then when you come back, the counter again becomes 0, right? So you are, so even though you did not went inside the page and each message that you received, you have not read each and every message, the counter still becomes 0, right? This is what we would want to implement. So newly unread message indicator, right? Not unread message indicator, but newly unread message indicator. So users can have hundreds of unread messages, but what 3 indicates is 3 messages that you recently received, right? And you have not acknowledged it, like something around that front. Did everyone got the problem statement? Because it's a little tricky to understand at first, but it's important to understand the difference. Yes? जिसको नहीं समझा वो बोलो, वरना फिर समझेगा नहीं आगे का. ठीक है. I'm guessing everyone got it. ठीक है. So we need to inform the users about presence of new messages, like unread messages, and obviously, like always, like anything, it needs to be near real time, because when you get the message, it should immediately pop up as 1, 2, 3 new messages been coming there, and upon new message received from the user, you would as in when you receive the message from the user, the count should change. And let's define what's unread for us. The number of new unread messages is equal to the number of people from which messages are received and unread, which means that even if you received 100 messages from a single person, for this design system, we would see that 100 messages from a single person implies 1 ka count. It would not imply 100 ka count. We can still do it at 100, a little tricky to handle, but to keep things simple at first, let's just restrict this to being like number of people from which you received message and is unread. So number of unique people, that is it. Okay. So let's start with brainstorming. How would you design this? How will you make this thing real time? How will you design it? What kind of data structures would you use? What kind of systems would you have?
It can just handle at the UI and at the Angular, telling like if there are any open like on.
But you are away and then you received message. Would you not render anything?
No,
you are offline and then you received messages. Then?
So the WebSocket will be connected, will be receiving the messages.
WebSocket would receive it, but you know your mobile is is shut down, your laptop is shut down, WebSocket doesn't exist there. Now what?
Would we use Kafka because once we come online, it will show that it was the last message. Like we read messages till this, and then these are the new members pushing to our queue, and it keeps on updating.
But then if you use Kafka, which means that you have read messages till that point.
Yes.
Right. So then you would your consumption would move forward till that stage. Right. And let's say you received 1,000 messages. So would you go would you go through 1,000 messages of Kafka without even acknowledging it? Like that's not a good solution. Nah? Let's say you receive 1,000 messages, or let's say 10,000 messages. For the first call, if you go through all of these things for all the users, that's the worst case, and then your system would start to fall apart.
Ideally, this should happen once we click on someone users, and then it should fetch all the data, right?
So all you need to render is count. So without actually, typically you should not be even reading messages at this stage, because if you are reading messages, which means like you are doing a heavy data transfer. If you're sending message data to the user, if you are not, at least you are reading it from Kafka and then discarding the messages, which is even worse. Right. So typically what you would want to do it is when the user opens your application on mobile app, laptop, whatever, you would get this count, just this count key. What's the count that you would want to render here? 2, 3, 4, 5, whatever it is.
So you would have to know the last time at which you were active, and so you only need it for your followers, right? So each of them have the times at which they are doing their posts, right? And
no, but it's the number of messages you received. Even if they were active, but they did not message you then.
So we can have a queue, right? And we can query the queue length, right? Without actually getting the message.
So for each user, you would want to have one queue?
No.
Not a good solution. No? Come on, guys. Think. We covered quite a bit of it. We can very easily design this. Sarthak?
I think we can have a table where we update the count whenever user receives a message.
Okay. Good start. Good start. Why? Because you're playing by the constraint, right? What do we need? We need near real time, right? And what do we definitely want? We want to show this count. So when something needs to be near real time, which means it has to be very lightning fast to, serve it. It always implies that you would have to store the pre-computed data. Store the pre-computation somehow. So at some place, some storage, you would need to store user ID to count. This would be your newly unread count. Right. So whenever your API wants to send the response, it would just come to this store. And from this user ID, it would get the newly unread count and return it. See, this is how you should be approaching design questions, right? So the things that I typically start with this. I typically start with input output, right? When we think about this now, you would start you'd start addressing one problem at a time, right? What we have decided, because what we would definitely want is you have to return in order one time, because it has to be very fast. you can't spend a lot of time doing computation ki what's the unread count. So let's say you would want to have a place where you are storing the newly unread count. Let's say Redis. So whenever your API is sending the response, it would just hit the Redis, get the data and send it. Okay. And if you want to keep it near real time, let's say we are using Redis for this because it is cached. We are not persisting it in the database. So let's start with a simplistic design and then we'll see if it actually makes sense or not. So we have our client. It will make this API call. It would connect to Redis, which would be the source of truth for my newly unread count, this one. Right. So next time, whenever your client comes online, it makes this API call. Let's say /me call or something. Right. So the first call that it makes to the system is /me call. And in that response, it would get, apart from all the basic information, it would get new count. This is the newly unread count. Let's say it come out to be 9. And this 9, this is user A. So in Redis, what would we have stored? We would have stored A, and against it we have stored 9. Make sense till now? So when we address any design question in general, we start by getting rid of the most simplistic thing or the most basic thing that we would want to do, like pre-computation, store it at one place to make things near real time. Let's use Redis because cache, and why not? And then we'll see if it did make a good design choice here or not. Okay. Now, if we have decided till this point, right, which means the gets are sorted. Right, so user making /me call, in the response it gets new count, gets from the Redis, so gets are sorted. Now what happens is, now the only thing that we have to worry about is how do we update the database. Now once we have decided this, the only question that we have to answer is how to keep count updated. That is it. Correct? Yes, no?
Yeah.
Right. See, this is how I typically take baby steps into solving the problem. Right. This is something when I was actually crafting, or actually this is something that I've actually built. So when I was actually building this is exactly what my thought process was. It just takes 5 hours to build and deploy this thing in production. It is not rocket science. Right. A very simple thing. You have to take those baby steps. Like, so typically this is how I think, like input output sorted, get is sorted. I wanted to make it real time. I used Redis, have this count sorted. Now my entire problem statement now boils down to, like, get is sorted now about writes. Like, how do I keep this count updated when someone sends a message? Correct. अब उस पे discuss करते हैं. Now, how would you do it?
Might be a bit expensive, but when someone posts something, then you get who follows him.
No, this is not following. No, this is you getting direct messages. This is newly unread messages.
Okay, got it. Yeah.
Right?
So then
people would have to message you.
Right. So so when someone posts a message, then the recipient, you go to his in the cache, I mean that value, and just do an increment.
Perfect. Not expensive at all, but a great start. Right. So the approach that is suggested is, so up till now in the first place, what we decided, we did a me call pe get and we got the update count. Now what we have to worry about is how to update it. So now let's say if B sends a message to A, right? What do we have to do? We have a Redis in place in which we did have an entry of Redis A. Okay, let's say the current count is 7, right? When B sends a message to A, this message, your API server could just make an update in Redis. Right? For every message that is being sent to A, your API server would figure it out and would update the corresponding count on Redis. And since it is Redis, just 3 millisecond mein your deal is done. Right. The approach that was recommended by Sanjit, most probably it was like do a count plus plus, right? But you forgot the requirement. The requirement said that the newly unread messages count is equal to the number of unique people who have sent you the message, but you have not read them. Right. Now, how would you do it? Like it has to be the number of unique people sending you the messages. How will you accommodate this requirement in this database?
A different data structure.
And
Which
one?
Sorted set probably.
Sorted
Sets or
set.
sorted set.
Sorted set. What would you store in the sorted set?
Yeah, so different user IDs would be
user IDs. Perfect.
And the timing would be the score probably.
Correct. So now what would you do is, so the count 7 implied that there were 7 people who have sent messages to A, and now B is also joined the party. So instead of storing 7, what if we store 7 user IDs? Let's say I, J, K, and now B is the latest one to have sent the message. Make sense? So now to render the count, instead of reading the value from the Redis, you would read the length of the sorted set from Redis. Correct? Make sense? So direct count nahi milega now, but now you'll get it from length. But a great advantage of this design is now what you can also render is somehow, if you are also storing like a basic detail, like let's say first name of the user, you can render like Arpit, Vishal, Manav, and Sarthak sent you messages. Like if you can also hold that information in Redis, right? You can actually render that. Like basically when you hover that part, you would see that thing popped, which says that Arpit, basically Arpit, Vishal, Manav, and Sarthak sent you messages. Right? So an extensible design, which would make it much more personal, just to basically instead of just showing that number. Right? So this allows us to do that. So user ID ke saath saath, if you can also add some basic information with it, that would be wonderful. Right? Now comes the part. What we have to do is once user taps on that button, we have to vanish the result. We have to reset the count. So what will we do? How would we implement that?
Yeah, so last click time of the user.
Why would you want to have click time?
I mean, just
nullify
that
please, Sanjit.
sorted set. Right? You can just nullify that sorted set. I just set it to empty again.
Exactly. So upon click, so whenever, let's say your user A, and you have your API server. So here you might call. So let's say when user is making a call /messages pe get. So when user is trying to read all the messages, case number 1, right? So when this call happens, you on your Redis, you would just purge the entire sorted set. Correct? So through this, whenever this API call is being made, where user is trying to get all the messages that he or she has received, one way, you might want to have a separate API handler altogether to do this job. Like a totally separate API handler whose job is to purge this thing. And that would be called every time you click that button. You can do it at 2 places, either on a button click, make another API call, or piggybacking with the API call that gives you the messages ka first layout ki what all people, what all messages are there, that API. In either place, when you'd want to like purge the count, you would just do this thing. You would just purge the sorted set. Now this way, what would happen is once you click that thing, the count would disappear because the sorted set is empty. And now when you refresh the page, when the API call comes here, when you are getting it, it would get from the Redis. Redis it would see what? An empty set. It would get the length. Length would be 0. So it would send new count as 0. Make sense? Yes. बस यही पे happen.
So Arpit, in this, would be good idea, like since like you are using a set, right? So set, let's say 3 people messaged me, and there's a count 3. Now, good idea to store the timestamp as well, because that way you can order the messages, and it will be instant. Like you don't have to check all the messages timestamp, go into Kafka and check all the timestamp. So this timestamp can also be stored, right?
In sorted set, you would always need to specify something. So you can specify the time. So this user at this time sent you the message. So depending on the most recent time, your set would be sorted. So you can use that to render the user list and see what happened. Like you would not be storing the actual message here, because like storing actual message might be too costly for Redis, because Redis memory would shoot up. And all you need is like users basic detail like name and user ID and the time at which it has sent, so that you can render it as most recent first. Let's say Sarthak was the latest one to have messaged me. So I can render Joy Sarthak, Manav, Vishal messaged you.
Yes.
Right? Something like that. So you can just store that basic information on Redis if you want to. Okay. Now that we have covered the most part, we'll just cover the basic nuances here. So this is exactly how our design is going to be. So to make anything near real time, use Redis, because the and obviously you can skip Redis altogether, use DynamoDB as well. No one is stopping you from doing that. We just pick Redis because all we needed was like fast, simple key value get. We don't want any heavy operation, any indexing whatsoever. And you should be able to distribute it across databases, shards, and whatnot if you want to do that as part of horizontal scalability. So to make anything near real time, this could be your golden rule. Use Redis. So Redis in general, any caching thing, this is how you would make things near real time. And you'd have a message status check API, whose job would be to make a call to Redis and check the newly unread count. So that part of me call, maybe an explicitly call that runs as a cron, or open a socket connection that would stream back this response here. You have a new unread count here. Anything around that is fine. If you are online, a WebSocket would give you a great user experience. Something that we discussed in the first week. You can pick that part. The idea is if A sends the message, B is there to check it. So if A sends the message to B, API would save the message in the database. Once the message is saved, it would go and update the Redis as well. It would go and update the Redis, say ki, I have sent message to B. B, since it's online, there might be a socket connection open. Your API server can actually do a broadcast from there to B, saying ki, B, you are online, you have a socket connection open. A has just sent you the message. That is why on LinkedIn or on any other website, you might just see a small red blink to have happened when you just receive a message, but you are online at that time. And due to some misconfiguration or some bug, you might see a red blink or the blue thing get open and close immediately. Like, so these are just basic handlers that they've applied. So in case if B is online at that time, if A sent message to B and B is online at the time, your API server can choose to send a message over WebSocket to B, notifying a new message has been sent to UB. Okay. And if B is not online, API server, because API server would have that information if B is online or not, because it would have a persistent socket connection open, right? Because it's a WebSocket. That's why. If B is online, then obviously you would not want to update the Redis. Correct? Because online and then you're also updating Redis, then why do you want to show unread count? Right? So you would have those checks key if you'd want to show, not show, depending on the product requirement. So you would have to keep both the sides open, right? About your approaches. And then your API server would also update on the Redis saying ki, A has sent message to B. So B ke against, you would add in the sorted set, add A key entry there as well. So when A sends the message to B, the new unread count for B should update or increase or add it to the sorted set. So we would have something like this. So user ID in a set, you would say that messages received from, so user ID 17289 received messages from these 3 user IDs. So then you would have this. So length of this set is equal to the number of newly unread messages. And now all we have to do is just keep this list updated. So when a new message is sent from A to B, check the set, make the entry. like make an entry. So your set data structure would take care of that. When a message is marked as read, check this set, remove an entry. Right? Very simple. So we have just like by fixating on the input output, we have basically pivoted our entire design around first deciding on the IO part of it. Once that IO part was done, it was very easy for us to maneuver our entire design around it, right? And then basically just a few checks that you can add is like if B is online or not, depending on which your socket connection could choose to handle. You would have an if else condition that you would handle that if B is online, do this, if not online, do that, right? And then depending on that, you would update your Redis counter now. So these are just extra product driven checks that you would apply, but the overall design would remain fairly same. Yeah, Ronak?
I might be wrong in this, but like I have a suggestion that if we are storing in Redis, that set is we are storing. Okay, so let's say you come online, you see 3 messages are there, and you can the messages are sorted in basically timestamp order. Like let's say Sarthak, Ronak, and Manav message. Now what we are doing is purging all of this, right? So instead of it, would it be a good idea to keep a count as well as the people who texted us, because next time when you come, you can gather the same information. You can just purge the count, but you can see the or like let's say you read Ronak's message only and Sarthak and Manav were unread. So next time when you come, you can see from Redis only that these are the unread, like dark or like bold color message will be there. So
yeah. So again, exactly. So I'm not denying that. So that was not part of our requirement. So if your requirement says that the people you have unread messages from or messages you have not read and you would want to show it on bold, you would do it for every message that you have not read. Yes. Right? So newly unread bold is different and unread messages are different. Correct? You might have thousands of unread messages from hundreds of people. Yes. Okay? You would have never. So when you will mark a message read, once you go through that left bay, you go through that person's profile, click on that, and on the right you will get the message box open.
Yes.
And that is when you mark that message as read. Until then, everything has to be bold. Everything as in every unread message has to be bold. So if you have 3 ways to differentiate between it. So newly read, newly unread, newly unread, unread, and old unread messages, something like that. Then you would take those calls, right? So a lot of things here would be driven by the product decision.
Yes.
Right. So typically, in most cases, you just have 2 states. So unread messages, once you open up the detailed message layout, that's where you would see the unread messages that you have. And all the people whose messages you have not read might come on top, and you'll see those people ke messages first. And everything would be bold, and then the people whose messages you have read would be there at the bottom half of it.
Right, like I was thinking that instead like sorted array, like what we are doing is sorted array count we are getting. Yes. So instead of it like purging the sorted area, we can just purge the count like for our notification.
Yeah, exactly, you can do that. With count also you can play. With a sorted array, what you are getting an advantage is like in the first API call itself, you can get like who all sent you the message, like A, B, and 23 others sent you the message. Like so that on tooltip hover you can render it.
No, I'm suggesting that we keep both because
you can keep both. I'm not denying that. See, if you have sorted set, uska length you can anyway find it on the client side. Right. So you can, instead of sending in count, you can actually send in the newly unread messages people list.
Yes.
Right? And render the list ka count or the list ka length as the count. And on hover, just convert the list to string and show it. Right. So that is a behavior that you would want. And then once you open the message box, right, and not read any of the message, but just open the message box, which means you have acknowledged the newly unread messages that you received. Right. So then you can just purge the sorted set, because now you have acknowledged that you know that you received messages from these people, although you chose not to read their messages.
Right. Got it. And one more question, Arthur. Like, whenever like you told about the tagging part, like and you're mentioning about let's say 60% width and like 10% height, we are tagging it. So once you tag it, like when you start writing anything, so all the things pop up. Like so, whatever closest friends pops up first, and then some username. So that we also look up into our following table only, right?
Yes, so that would be a following table. Usme position was the one that was a sorting criteria.
Yes.
Right. So that position could be your affinity score. Like how, like what affinity do I have with the people I follow? Like if I'm reacting to a post of a certain person very much, I might just give a very high affinity score to it. So that position key value will be a cron job that would change the position value of a person's puri follower list.
Right, and if you are like searching for a random person, let's say, so it will be a try base, right? Like Arpit, ARPIT, Bhayani, like it will be like it will search in a try basis, right? Like am I right in that?
Twitter typically does that. Twitter typically does that, but there are more complex algorithms here where you have similar to LinkedIn. Like it would first check within your level 1 connections, then level 2 connections, and then level 3 connections.
Okay.
Right. Usme you can also add a tadka of famous people. Like let's say if I type in SSCH, what are the chances that I would be searching for some of my friend called Sachin versus Sachin Tendulkar? Right. So it would always show me Sachin Tendulkar at first. So you would always go through all of these things. So this would be like again a bunch of product decisions that you might want to take here. But first search into celebrities, then search into your level 1 connections, level 2 connections, level 3 connections, and then throw them the result.
Thanks, sir. Thank you.
Yeah.
I guess they kind of build on top of your kind of search history to like the people kind of profile. Was a pura recommendation.
So in the today's world, search is not just normal text-based search. It a lot of ML and DL has gone into it. A lot of personalization has gone into it. A lot of data is taken as input, search logs and whatnot. So when I was building search at Unacademy, we took in so much of data because we had to make it everything like very personalized to it. And just normal TF-IDF won't do a good job into surfacing the most relevant content to the user. So you'd pull in a lot of data from here and there.
So those models kind of run in real time or
real time. It's very cheap to run those models. So models just run on like 10 different machines, and they just constantly spit out for this user. Give me the users that could be relevant to this, and it is frequently pre-computed on events that come in. It's a little complex architecture, but not that difficult as well. So a model training. So basically, models are trained every. In our case, models are trained every 8 hours. For every user, we have an entry. Depending on that, for all the candidate results that we get, we then rearrange the results on that. So let's say we want to send 10, we fetch 80 out of it. And then from that 80, we rearrange it depending on the model, right? And how that model would pick in features. Like, let's say I follow a lot of mathematicians, right? So people who are tagged as mathematicians would get higher weight. So model typically help me in sorting the candidate set.
Okay.
Correct. And then I just skim the result. So out of 80, I pick 10 and send.
Okay. So basically, like you just get the first result set, and now on the basis of what user has affinity towards.
Yeah. वो ऊपर जाता है बस, जैसे ऊपर नीचे चेंज होता है, बाकी everything remains the same.
Okay.
Few things that you should definitely think about is how would you design groups, like closed groups, custom groups on database. Start with SQL and then move to NoSQL. How would you design it on SQL side? Messages, storage plus real time, like Instagram messages and all. Like you can piggyback the discussion with the sockets one that we had in the first week on making things near real time, scaling sockets and all. But how will you have messages? Think of Slack. How will you design Slack's messaging system? Right. So socket wala part is already done. Real-time communication is already sorted. The one we discussed in the first week. It's just about DB design, right? How will you do that? Read Twitter's engineering article on trending hashtags. It's a very simple read, but since the content is already available, for me to like reiterate on that did not make sense. So you can go ahead and read it. Twitter's it is officially blog on Twitter engineering. You'd find trending hashtags, how they do it, and this is you'd see the complexity at which Twitter operated back then to determine trending hashtags, and then also try to model comments with hierarchy. So comment, then reply, then reply, then reply, then reply, like having an infinite depth. Or if you want to restrict it at some point, how would you model that part on database? So if you restrict it at one level hierarchy, if you see Slack, Slack, yeah. If you're on social network, let's say Facebook, just said comment, right? And now they changed it to about 4 or 5 years back. They added reply button as well. So when you reply, it gets replied as part of that comment. So they have this one level depth tree sort of structure. If you would want to model this sort of hierarchy, how would you do this? Another example here could be, how will you model Twitter threads? So it is simple to identify. Just use Twitter API to see the kind of response structure they have, and you will understand how easy it is to implement Twitter threads, because Twitter threads can go up to 100 tweets which can be threaded, right? Think about that. So comment hierarchy, 1 level, 2 level, n level. Right? How will you do this? Then I've already posted a video of notifications of Instagram from my first code. Go ahead and watch that. I'm planning to add a couple of more videos on system design on my channel, but at least for now, go ahead and read how to build notifications at Instagram. Since I already had it covered, so try to like reiterate the same thing. You can go ahead and watch that video. It's exactly how I would have taught again. So do this notification at Instagram. Okay, so this is must, because and that I've discussed scaling Kafka, SQS versus Kafka, importance of event bus for notifications. How would you handle multiple priorities of messages to ensure minimal delivery time? What kind of monitoring would you place in? What's the key metric that you should be tracing when you are building that system? And a very interesting design choice and a few gyan ki batein about like about 10-year challenge, and why did Instagram or YouTube implemented the press the bell icon stuff. So a lot of discussions about 37-minute long video. I typically rant a lot, so yeah, you'll find that amusing, but I've definitely covered that in depth. And yeah, okay. Basically that is it. Any questions? Good. Okay. Next week. Yeah, go on, Rahul. Happy.
It's based on the last class. So regarding the hashtag architecture, you mentioned there are 3 ways to improve the cost efficiency.
That is something that we discussed at the beginning of the class. Where I'll definitely reiterate. If there are no other questions, I can have a chat about it.
I just joined late for this class.
Yeah, abhi kar lete na.
One question. So from what I kind of see across now the 4 weeks, database design kind of plays a very crucial role, right?
Very.
So, like how do you at a later point of time like galat design like
regrets?
Okay.
Regrets बहुत होते हैं, बहुत. But
like, because business requirements can change at any point of time, right? So
yes.
Like, is it like you do you remodel the entire thing or set up a team to remodel it, or
see
generally
SQL mein, when you know that you basically fucked up with the database design and it is not extensible due to future product requirement, this is where your architect has to be blamed. It's job of the architect or senior people to ensure that you at least can attain scale for like next 2 to 3 folds that could be there, like 2 to 3 change in requirements could be there. It has to be there. And if it is not there, like for example, just naming your table from follows to relations is a good design choice, right? Having a strategy to accommodate newer changes. I'll give you one very quick example which I discussed with Sarthak about designing Slack messages. Like, so in Slack, you can have a one-on-one communication and a group chat. A naive design could be to have a separate thing for one-on-one communication and a separate thing for group communication. But what if you model, if a good DB design could be your one-on-one communication is nothing but a group communication where a group contains just 2 people. So even a one-on-one communication is a channel for Slack. And you can at any point of time add multiple people to that combination. So this gives you future extensibility, allowing you to convert your one-on-one to a channel, right? And have no massive difference in it. Right, so this is what a good DB design is, like just understanding the future changes that might come in. Okay, but if you have made a blunder, if you have made something around it, so there are 2 ways to do it. Either you can fix it or you can rebuild it. In most cases, when you make blunders with SQL, it is very hard to fix it, but it is very easy to remodel it, right? So that is when you would have a parallel microservice or a parallel part, and from the API call, you might check if version is 1 or version is 2. You would either go to your legacy one or the new one, right? Because with SQL thing, it's very hard to fix it because SQL may alter columns and all of these things are too costly, and once your table grows very huge in size, it would choke up your database performance a lot. So that's where you typically move out and try to rebuild your system with not this is where it is called as reducing the technical debt, right? So once a while, typically you should invest time into reducing the technical debt. Dream11's CTO most probably just posted that they have this 6-week drill that once every 6 weeks, 6 weeks or 6 months something,
3 months, I guess.
So they have this special phase where they just try to minimize the technical debt, and they pick up any of the tasks that they would want to fix things on. Like they know that this is the technical debt, this is a poor design choice that we made, and we should be fixing it for us to move faster. So you either fix it or you rebuild it.
Yeah, and like that also kind of defines like in general we use products and say कि ये छोटा सा feature क्यों नहीं डाल पा रहे. So it kind of
this is why it basically doesn't happen, a technical debt.
Okay. Yeah.
Well, as simple as that I just want to add like close friends into my system, and why is it taking so much of time?
Yeah, because अब import करना पड़ेगा या फिर rebuild करना. It will be okay. Got it.
Any other question, guys? ठीक है, चलो. हाँ, Rahul. ठीक है. Others can drop off if you want to. If you want to stay back. I'm more than happy to chat. Rahul, to answer that, optimizing the time would be basically batching the events that you get. Like what we discussed, doing a count plus. So for tag ka post count was there, right? So for each tag, you would want to see the number of posts that tag appears in. So here, a great optimization would be the concept that you would be giving up would be real time, like not real time, but basically accurate showing of counts of the number of posts that is tagged with that particular tag. If we give up on that and we make it approximate, let's say eventually it will catch up, right? So you can batch a lot of stuff. Once you batch it and then you make it, so instead of doing count plus, you do count plus equal to k. Let's say every 5 minutes you do one, right? This way, what you would save on, and why this is cost efficient, is because you don't have to over provision your database to handle this much of writes, right? Because just imagine doing write or basically doing count plus versus doing count plus equal to k. You're directly slashing your writes by k. Correct? So you are reducing your IOPS. Right? So always batching always plays an important part there. Okay? Yeah. Second case is if you can rely on approximate algorithms called online algorithms. So you can have approximate counting versus accurate counting, which would save you space. And it would basically further down your count or your count updation strategy. Let's say you slashed it by k. Now you would want to make it even leaner. Let's say I like after a million, then let's say you are showing 1.1 M and then 1.2, 1.3, 1.4. So it would not matter if it is 1.2 or 1.3, or if it is 1.24 something something something, or 1.21 something 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 something. So you can have that approximate. So as and when your count increases, you can reduce the frequency of writes and make it more and more approximate. That is how you can save a lot of writes that go to your database.
So do we need to maintain another database to make sure that a post has crossed, or like a hashtag has crossed like 1 million to make
You can
it
have, you can typically do that, because when you are writing it, you don't have to use another database. You can use the same database, but you can make your K variable. Like basically, what's your batch size? So you might want to store intermediate result at some place and do write at other frequency and all, or you might want to hold a batch at some different database, and that's over engineering. I agree, but it's a good design. It's another design pattern that you can follow, right? But the idea is reducing the number of writes to reduce the number of IOPS that happen on the database, which save you cost. Any other question?
And Arpi, just one more thing. So if a hashtag has a billion photos, like why can't we remove all the 1 billion? Because like people don't scroll like 2 billion photos. So why can't we chunk
So
it
people
under
easily, people typically for the hashtag or for the photos, people typically scroll till 500.
Yeah.
Right. So you won't be deleting it, but that's why in yesterday's design we had this popular photos.
Yeah.
Right. In that popular photos, we would just give 500 photo IDs.
Okay.
Right. We would not be storing all 200 billion. We would need a way to go through all of them, but to render that photos page very fast, we would just load those 500. We would just send back those total 500 photo IDs there.
So I was thinking like why can't we chunk out all those data, because it's already published, but it's already assigned to a user and it'll save a lot of space.
Yeah, you can delete it. You can delete it. I'm not denying that.
Okay.
You can delete it. You can delete it. See, then it's a business call. You can save space. If space is a concern, you can delete the entries if you want to. By deleting the entries, you would get benefit about a database performance boost and all. You can get that. But it's mostly a product call around that, because like tomorrow product might not come and say, I want all the photos to be scrollable and all. Like it's just about having a confirmation from the product team about it. Okay. Yeah, nice. Any other question? Okay, awesome. Thanks a ton, guys. Next week we'll be doing storage engines. I'll put out agenda anyways. It's anyway published, but I'll obviously drop you all an email about it. And see you guys next week. Thanks a ton. Bye-bye.
Thank you.